Hello all, welcome to the second lecture in the lecture series DIP Lab through Octave. In the last lecture, we have discussed about the Octave, how to download it, how to install it, and I have told some of the basic commands which we can use to perform image processing operations. So let's start. This is our Octave window, Octave software. This is command window, workspace, command history, and this is file browser. So first of all, I will change my directory to the folder in which I want to work. So I will press here, and you see this folder is appearing here in the suggestions. I will choose this, and now you can see these are the files available in the folder. Now let's clear the command window CLC. Now today we are going to discuss the image histogram and histogram equalization. So this we have discussed in the theory classes. So how to calculate the image histogram, that we will see first. So just to calculate image histogram, we need to read the image first. So let's read the image in variable I equal to I equal to I am read, and then in inverted commas the file name cameraman dot with extension jpg and parenthesis close semicolon, so that we don't see the intensity values of each pixel. And now we have read the image into variable I. Now to perform to calculate the histogram, we have the function I am hist. So I will type I am hist. This is a function, and I will pass I as an input argument to this function. So it will give us the histogram of this image. So okay, it gives us a warning that um, the imHist function belongs to the image package from Octave Force, which you have installed but not loaded. To load the package, run pkz load image from the Octave ROM. So what we need to do, we need to load this package before using this function. So what it says pkz space load space space image, right? Now this will load the image package, this package in which histogram is available. So now we will use this. So now the uh, function is I am hist, and input argument is I. So I am hist I. So now you see this gives us the histogram of the image. Now histogram, as we already have discussed, on the independent axis we have the gray level values. So we know in grayscale image the gray level ranges from 0 to 255, 0 to 255, and on y axis, that is dependent axis, on that we have number of pixels containing a particular intensity value. So we can say, like for this intensity we have these many number of pixels in the image. For this particular 50 gray level we have these many number of pixels. So like this, for each intensity level we have a certain number of pixels in the image. So this is the distribution of the gray levels in this image, right? So hope this is clear. Now let's explore this imHist function. So the Octave provides us the help package. So to know a function, we can search for the help. So for that we have the keyword help, and then space, and whatever functions help we want to know, and we type that function. So I am hist is the function. So after help we have to type the function name. So once I enter this, I will get the details help of this function. So now you see this we can use in these three formats, and here you can read the details about this function. Now here you see that in the second, if we want to convert, if we want only n number of bins in the image, then we can pass the second argument in the input. So let's see how we can have bins in the histogram. So I will pass this time the second argument to I am hist I comma 5. This means what? The first, the gray level range will be divided into 5 bins. 5 bins means 0 to 50 one bin, 51 to 100 second bin, and so on. There will be 5 bins. So this you see, this is 0 to 50, 0 to 50. Total 51 gray levels. They are in the first bin, and in this we have the gray, the number of pixels which are here. 51 to 100. This is second bin in which we have less number of pixels. Then 101 to 150, sorry, 100 to 150, we have the pixels in which we have most number of pixels which are there with this intensity. Now this is your 150 to 200 and 200 to 255, like that we have these bins. So now this whole gray level range has been divided into 5 bins, and then in each bin in this range how many pixels are there, that is represented by uh, this stem, and in this range how many pixels are there, that is represented by this stem, and so on, like this. So we can use this I am hist in this form too. Now let's write a script to calculate the histogram of an image, and then uh, we will equalize the histogram. So we will use histogram to enhance the image quality. So before going to the script, let me introduce to you the function we use for image histogram equalization. So now the function we use for histogram equalization is hist EQ, histogram equalization. So hist EQ is the function. So that will equalize the histogram of the input image, and input image here is I. So in J we have got what, the equalized image, histogram equalized image we have got in J. Now the output of this function will be double. So we will convert this into unsigned int, and then we will display this image. So let's write the script for the same. So this, I have opened the new script from here, and then I will save it first, Control S, and I will use exp1 is the name, and extension is .m already there. We need not to change it. Save. So the first command we use is clc, so that all the command window will be cleared. Then we will use clear all, it will clear the workspace. Then close all, it will close the all the figure windows which are open. Then what we will do, we will read an image. So I is equal to, now you see, if we perform this histogram equalization on a general image which has the histogram distributed all over the range of gray levels, then we will not be able to see histogram equalized image uh, quality. The quality in between the input image and output image will not be that much difference. So for that, I have, what I have done, I have downloaded a low contrast image, and I will open this image. I will calculate its histogram, and then I will equalize its histogram, and then I will display the output image histogram too. So then we will be able to uh, compare the input image and output image, and we will be able to say that yes, the histogram equalized image is having high contrast than the low contrast image. So I have downloaded one image from the internet, and then we will use this as the input image. So first I will read this. So I am read in single quotes or double quotes. Low contrast is the file name, the image name, jpg. .jpg is the extension. I will read this. Once I read this, now I will display the original image, its histogram, the output image, histogram equalized image, and its histogram in a single figure window. So for that, what I will do, I will use subplot, and I will, since I need four positions for original image its histogram and output image its histogram, so I will divide it into two rows and two columns. At first position I will display the first input image, so I am show and then the variable I. So this I will display. Then on second position, subplot 2 comma 2 comma 2. At second position I will display the histogram of this image. So I am hist, and then the I as the input argument. Then what I will do, I will equalize the histogram of this I, and that I will store into the variable j. So j is equal to hist eq, histogram equalize of the input image I. And then I have to, since I have told you that the output image class will be double, so I have to change that back into the unsigned int. So j is equal to u int 8 of j. So that means I have changed, I'm changing its class from double to unsigned int. So that I have done here. Now I have evaluated the histogram equalization. I have done, and then I have converted its class. Now I will display it. So subplot in the same window 2 comma 2 comma third position. Two positions we have already occupied for the original image and its histogram. At third position we will display the histogram equalized image, which is available in variable j. So I am show j. Then we will evaluate the histogram of the output image, and that we will display at the fourth position. So subplot 2 comma 2 comma 4, and I am hist, and the j as input. So that's it. What it will do, it will simply first display the original image. We read the original image first, then we display the original image on the first position, then we display its histogram on the second position. We calculate its histogram equalization. For that we have the function hist eq, and then we change its class from double to unsigned int 8, and then we display the histogram equalized image and its histogram, the third and fourth position of the subplot. Let's save it, control s, and run this. Okay, so oh, let me see what is the problem. I guess I am so j, we don't have to, okay, so the problem I have got, we don't have to convert that into, yes, we don't have to convert that into unsigned into. Why? Because in that case these intensity values are rounded off to the zero. Intensity values, these values are rounded off to the zero So we need not to convert that, and the double class also will be displayed. So now let's analyze. So this is the input image. This is the input image. At first position we have displayed the input image, and its histogram is populated in this range of the gray level. In this range of the gray level, in very short range of the gray level, the histogram is populated. That means in this image most of the pixels intensity varies from this point to this point. Now here we have equalized the histogram of this input image, and the histogram equalized image is this one. Now this we can obviously say that it is high contrast image, since uh, the details in the image we are able to see very clearly, and its histogram, if we see, its histogram is distributed all over the range. And one more thing is, the output of equalized histogram equalized image will, its gray level will range from 0 to 1 only. It will range from 0 to 1 only. That is why when we were converting it from double to unsigned int, it was becoming 0. So that is why we were seeing a black screen there. So so you see its gray level ranges from 0 to 1. Now if we want to convert it to 0 to 255, we can multiply j by 255. So that will convert that into the range 0 to 255. Now this is the output of output image histogram. So here we see that its histogram is uh, distributed all over the range of the gray levels. So 0 to 1, it is distributed evenly, and here we can see the details are clearly visible. The grains we can see perfectly, dots are visible perfectly, and here the low contrast image has become a good contrast image at the output. Okay, so now I want you to explore this subplot in the help, and try to label these images in the figure window. Like uh, this is the input image, this is the histogram of the input image, this is the output image, and this is the histogram of the output image. This I want you to do it. So you explore this subplot in the help, and then try to label these images. Okay. Thank you for watching. That's it for this lecture.